absent, you used a homework pass, whatever the case may be, you are doing this problem with us. All right, you're actually writing this problem down completely. All right, it says find the percent of change, describe the percent of change as an increase or a decrease, round to the nearest whole number. All right, so I have 36 and 1/2 is what I'm going from, and I'm going to 29 and 1/4. Now, you have two choices. The funky thing, so remember, your percent of change equals the amount of change divided by the original times 100. I have to see that whole formula. These numbers are a little different than the other numbers that we've had. Why? 17 through 20 are different kinds of numbers than the ones that we've seen. Why is that, Peter? Yeah, because they all have fractions. If you notice 17 through 20, they all have fractions. All right, it was really easy to do this when we had whole numbers and we had decimals, isn't it? So what can we do to our given? Come on, sit up, Chris, all the way up. Pen in your hand, you're helping me out. Everyone's thinking, what can I do to my given to make life a lot easier for us? Serena? Well, I can't make 36 halves a whole number, 36 and a half a whole number. I could make it something else, though. Kaylee? A decimal. What is 36 and a half as a decimal, Kaylee? So this is 36.52. What is 29 and a fourth as a decimal, Kaylee? Yep, 29.25. I do expect you to know your decimals. If you don't know the equivalent, decimal equivalent of a fraction, how could you figure it out? So if this was like 36 and 7/8, I would not necessarily expect you to know what 7/8 is as a decimal. How could you figure out 7/8 as a decimal? Chris? Exactly. You're going to divide 7 by 8. You're going to do that division. All right, but we know these. So I'm going to go ahead and do my formula. Percent of change equals 36.5 minus 29.25 divided by. How do I know what my original is for any of these? Because that is really important. Colin? Yeah. It's the one we're going from. It's not always the smaller one. It's not always the bigger one. So in this case, it's 36.5 and then times 100. I have to see all of this. If you're missing any part of this work, you're not getting full credit for your work. All right, so 36.5 minus 29.25. This gives me 7.25 divided by 36.5 times 100. So I'm just going to say 7.25 divided by 36.5. And I end up with 0.1986. And I'm just going to put dot, dot, dot there. I wrote it out all that far because I need to check. Round to the nearest whole number. So if I multiply this by 100, it's 19.9. If I rounded, which is approximately 20%. All right, and they ask for it's an increase or a decrease. Is this an increase or a decrease, and how do you know? Ashton? Why? Yep, I'm going back to my original and being like, oh, I went from 36 something to 29 something. That's decreasing. Who asked me for that? You cool with that? Awesome. What else can I do from 4.4? Nick? 15. Let's take a look at 15. So 15 said that we have 26.2. We're going from 26.2 to 22.8. Nick, what's the formula? Yep, of the start number or the original, and then times 100, right? Yeah. Okay, so how do I find, Chris, sit up. How do I find my amount of change? minus,
minus 22.8.
yep, so you have to find the difference between those two. That's the amount of change. And then what was our original number? 26.2, and then times 100. Is that what you did wrong?
Yeah, I didn't see that.
But you didn't look at your notes, and you didn't think about the formula.
Yeah,
Okay.
I wrote it in my notes.
I'm sorry, what did you say?
I wrote it.
You threw away your math notes notebook.
Because I wrote
Did you just say you threw it away because it was full?
Yeah.
Okay. Did some of that have chapter 4 notes in it?
Oh no, I wrote those out.
Okay. I'm so happy that you thought of that.
And then I
What do you have at the end of the year? What do we have at the end of the year? Haley, a final. That's on everything. Do you know what one of the biggest things that high school students who have had me have come back and told me they use all the time? Their notes. So, here are two very, very important reasons why you're not throwing your math notebooks away. For sure you're not throwing them away halfway through the school year.
I got organized.
There's nothing more that is anything positive that's going to ever come out of my mouth with this discussion. So I think I got my point across and we're done with this discussion. Is that a fair statement? Excellent. How about 4.5? What can I do from 4.5? Ashton?
I just had a question.
Yeah, please.
So on the ones where it was like the answer's like 3/25, for example, like the fraction, final answer on that, I had that, but I didn't have a single final. I just made like my answer was like a decimal. So like number 3, the answer was 5/7.
And you put it as decimal?
Yeah, and then, so like I had 10/14, which I could have simplified to 5/7, but I made it 71.4%.
That's fine. Because that's actual data, right? That would be experimental to me. And we've talked about experimental probability having a percent for their answer. That's fine with me. Yes?
The finals test, like, does it go on your grade or is it just like a test? Like, does it go on like your math grade or is it like the
Okay, so do you think that I would give you a math final that would have no significance at all, that I wouldn't even grade and it wouldn't impact you? Do you really think that would happen? No. It is part of your grade. It's a final exam. It's a big, big part of your grade. It's a final exam. So let this be a very valuable lesson that you have just learned in 8th grade that you don't want to learn in 9th grade, because in 9th grade, your final's like 50% of your grade. Yeah. So do not get rid of anything when it comes to notes in a class until the very end of the school year, and you might want to check with the teacher, particularly math, because it all builds. Okay, get your notes out. Lord help us all. Thank you for that comic relief. Thank you for that comic relief. It's good to laugh sometimes, isn't it? Okay. Today is the 14th. We are still in chapter 4, section 6. No, we are in chapter 4, section 6. We're just starting it. What we're talking about is compound probability. Now, I want you God bless you. The word compound, I know we have seen it before. We've seen it before in compound inequalities. We now see it in compound probability. The only commonality in this is just what the word compound means. Compound means that more than one thing. That's all it means, is that we're doing more than one thing. In compound inequality, we had more than one inequality that we were solving. Those were the ands and the ors. That's not what we're doing here, but that's what compound meant in that situation. Here, compound probability, in our situation here, when we have a compound probability, what that means is it's the probability of two or more events happening. That's what compound probability means. It's the probability of two or more events happening. We're going to do some examples, but I want you guys to have in your mind, you're like, oh, that makes sense. So an example of that might be that we are rolling a blue dice and a green dice. All right, and we want to find the probability of rolling a 3 on the blue dice and an odd number on the green. This is one possible example of a compound probability. We have two dice. We have a green one and a blue one. And we want to know the probability of finding two different things. We have the probability of rolling a blue 3, and we have the probability of rolling an odd green. So there are two different events we're looking to find the probability of. Okay, there's one formula for compound probability. It's the same formula for all types of compound probability. All right, the probability of A and B is equal to the probability of A times the probability of B. So we find the probability of the first thing happening, we multiply it by the probability of the second thing happening. That's the formula we're using always. Just like the probability of just one thing, whether it's experimental or theoretical, it's the same formula. So this is a formula we're going to be using. Questions so far? Who needs to see what's up there? Okay. There are two types of compound probability. We're just going to do one today. So two types of compound probability. The first one is when we have independent events. The second one is when we have dependent events. We're going to focus on independent events today. All right. Independent events mean, what this means is the result of the first event does not impact the second event. That's what independent events means. The result of the first does not impact the results of the second. All right, there are actually two different types of independent events. So my first type, one is going to be when we have two completely different events happening. Two different things happening. All right, an example of that is what I've already talked to you guys about. And we're going to do that example with the two different color dice. So here is this example. So we have a blue dice and a green dice. We want to know the probability of rolling a 3 on blue and odd number on green. So these are two completely different things happening because we have two completely different dice. We roll one, we roll the other. So these are two completely different dice. Obviously, whatever I do on the blue is never going to impact whatever I do on the green. They're totally separate. All right, so I'm going to use my probability. I'm going to say 3 blue and odd green equals, well, it's the probability of a 3 blue times the probability of an odd green. So now that's our formula that we're using, and now we're going to use our singular probability formula to do this. All right, will someone tell me, what is the probability of rolling a 3 on our blue dice? Peter? 1 out of 6, because there's 1 3 out of the 6 sides, times, so that is the probability of rolling a 3 on the blue. What is the probability of rolling an odd on the green? Matthew? That's our 3 6. I'm just going to show you where these came from. And now, all you're going to do is multiply. All right, I'm going to divide out common factors here. All right, so I can divide out common factors between any numerator and any denominator. I'm just going to simplify this second fraction. That ends up being a 1/2. And now we just multiply. So my probability is 1/12. All right, and I want you to leave as a fraction. You're going to leave it as a fraction. Questions? All right, let me give you guys another one. In your homework, they're going to say number cube. Number cube is a dice, just in case you haven't figured that out. Who needs to see what's up there? Okay.
Attention students, please pardon the interruption. There will be no rehearsal for the choir during lunch today. No rehearsal for the choir during lunch. Thank you.
All right, so here is my example. We are rolling a 30-sided dice. I used to have one, but it got stolen. All right, we're rolling a 30-sided dice 2 times. We want to find the probability of getting a single-digit number, the first roll, and an even number, the second roll. Now, this is independent because we're rolling them completely independently. It doesn't matter where I get on my first to get my second. All of you do this, please. Start with the formula. Probability of first single digit. Second even. So it's a probability of first single times probability of second even. There's my formula. All of you do it, please. You have a 30-sided dice. Chris, can you read it? So it's a probability of getting a single digit on the first roll, getting the even number on the second. Jacob, what is the probability of getting a single digit on the first roll? 9 over 30, because there are 9 single digits out of the 30 sides, times, what's the probability, Jacob, of getting an even number on that 30-sided dice? Yep, because half of them are single digits. How many of you guys got that? All right, now I'm going to divide out common factors to make life considerably easier. So 15 is going to become 3. 30 is going to become 6. I can divide out common factors in here again. That's 1/2. So I end up with 9 over 60, but I can simplify this again. So that's going to be a 3, and that's going to be a 20. So it's 3/20. How many of you guys got 3/20? Awesome. Okay, so this is one of them. Questions on this one. This is when your two events are completely separate from each other. All right. The second one is when we have one pool of stuff, but we're replacement. So this is something called with replacement. And the only way that I can explain this to you is by giving you examples so you can have an idea of what I'm talking about. All right, so let's say that we have a deck of cards. All right, we have a deck of cards. We want to find the probability of picking a queen first, replacing the queen, then picking a 2 the second time. If you notice, we're putting that first card back in the deck. So whatever we get the first time does not impact the second one, because we're putting it back in the deck. That's what with replacement means. So whatever I get the first time does not impact whatever I get the second time. Okay? All right, that's what replacement means. All right, so probability of queen, then 2. Equals probability of queen times the probability of a 2. How many cards are in a deck of cards? I hope you all know this. How many cards are in a deck of cards? Nick? No. 52. So we have 52. Shh. We have 52 in each deck. So now you've got to figure out how many queens there are and how many 2s there are. So how many queens are there in a deck of cards? God, I hope you guys understand a deck of cards. Blythe? There are 4 queens in a deck of cards. Blythe, how many 2s are there in a deck of cards? 4. All right, let me ask you guys this. This does not impact this. What are the suits in a deck of cards? What are the different suits in a deck of cards? Chap?
Spades, clubs, diamonds, and hearts.
Excellent. How many face cards are there in a deck of cards? Like, what are the face cards in a deck of cards? Shh. Kings, queens, and jacks. Okay. Deck of cards. If you're not sure, go play cards. All right, simplify this. All of you finish this. Shh. So what do I get as my final answer here? Serena? I have 4. I don't think so. Both of you get out. Now. Colin, you're with it. Get out, both of you. Out now. You go stand by the lockers. I don't want to hear a word. Leave the door open. So if I divide out common factors between the 4 and the 52, I believe 52 divided by 2 is 26. So that's my mistake. That's 26, which means I can divide out common factors further. So I'm not saying you're wrong. Let me figure this out, though. That becomes a 1. This becomes a 13. Okay. So now I have 13 times 2, which gives me 13 times 2, 13 times 13, which gives me, I don't disagree with you necessarily, that's 169, and this ends up being a 1. Nice job, Serena. Questions on this? All right, so you have 2 different situations. You have, this is independent events is what you're doing. One is going to be where one does not impact it at all because they're totally different. The other is going to be when you have with replacement. Do you guys understand? All right, you guys can get going. Nick, what's up?